Good morning, everyone. I'm Divya and she's Neha from University of Nottingham. And we are presenting the adaptive ventilation strategies and their impact on operative temperatures in a warm and humid climate. So we chose the Kanchenjunga apartments designed by the architect Charles Correa, which is located in closer to the coastal region, which is the Arabian Sea, and it was strategically designed to capture the sea breeze, so it could work on a concept of natural ventilation, which is coming through the verandas or the terraces. So the structure is made mostly of concrete with a whitewashed stucco finish. So the climate of Mumbai, it fluctuates between 17 to 33 degrees Celsius with a mean annual temperature of 27.7. But even during the winter, the mean average goes up to 33 degrees Celsius. Basically, it is hot almost throughout the year. And the air quality index study shows that it is termed as unhealthy with comparing to the standards of WHO. And from 8 a.m. to 4 p.m. is the peak time of the pollution as per the AQI index. Next. So we selected four different units or on different facades so that we could and on different levels so that we could compare the studies to understand how the units on the lower level and on the highest level are working, because it was basically designed for natural ventilation at the time of construction. So we all the living spaces, the living room is a double heighted space, and almost all the openings are covered, are kind of like protected through a terrace or a veranda through which the ventilation was supposed to work. And since the stack effect is working through the veranda space, and through the staircase it's reaching on to the upper level bedrooms. And we did study the window to wall ratio, which is 24.2% for the living room. It's comparatively on the southern facade, the openings were reduced to limit the heat gain from the southern facade.
So this was the original building design that we saw. Now, what we tried to do was we saw the air quality index, which was very bad during the summer and the winter period. And we assumed that from 8 a.m. to 6 p.m., we closed the window. And from the weather index, uh, we chose the lighting gain, the comfort zone was taken to be 18 to 30 degrees. And we took the U values and we assumed four cases. One, where the windows are consistently closed. Second, where there's only nighttime cooling. And the fourth case, where was when the air quality index was good, the windows would be kept open. And it will work on an operative temperature. The window will open when the temperature is in between 20 to 30 degrees. So first result, we did a CFD simulation to see how the existing airflow is passing through. And we found that the cold air is dissipating everywhere around the house. So the stack effect is working fine. But when we see the thermal results, we see that if we close the window all the time, 96% of the time, the people are in discomfort. But if we use the operative temperature, it goes down to 28.2 degrees. And while if we keep the window open all the time, which is the case too, it is 33.3 degree when the people are in discomfort zone. And I have found out the peak temperatures as well, which I have shared respectively. So the peak temperature of case 1 till case 4 is reducing gradually. We see that in all the bedrooms. So with the volume, which is the highest volume is in living room and the lowest volume is in bedroom, we see that operative temperature is helping through uh, if the windows are opening through the operative temperature, it is really helpful. And that is how what our discussion is based on. That nighttime when opening the window through specified temperature dependent opening time is way better compared to nighttime cooling for our situation. The conclusion is, even though natural ventilation is solving a lot of the problems, we would still need mechanical cooling for the houses, because 30 to 40% of the time the people are in discomfort zone. And well, I think the high thermal mass of the building is also playing a role, while the window wall ratio is well balanced. So the building is naturally cooled, which we see in case two. That's all. Thank you.
First of all, I think that we have two presenters rather. I only presented one. I don't have the name of
The group.
It's a study.
case
We do it.
So
And Neha, she's the
Divya.
I just wanted to acknowledge both of you. Thanks for your presentation. I just have a question just for clarification. I don't know if it was clear to everybody, just not to me. Is this an existing building, right? And this is a well-known building? Yes. Did you mention this at the beginning? Yes, you did. So I didn't catch it. Okay. Is it Charles Correa's building? Yes. Okay. Okay. So you didn't do any field work, did you? Okay. And so the whole study was based on on your simulations. Okay. Is there a reason why you didn't get to do field work, or did you have the chance? I can imagine the answer, but did you have the chance to look at previously done field work? Because I think it's a very well studied building.
Yeah, we did have a chance to see the previously done work, which was mostly on understanding how the natural ventilation strategy is working. But we wanted to see the adaptive ventilation strategies, so that's what we worked on.
Did you have the chance to compare your findings with what was studied in field work in previous studies? Did you make that comparison at the end?
No, because the other one was just defining if it is working or not, and ours was mostly seeing that what can be enhancing the thermal comfort.
Any other question? Maybe we have time for one more question. I don't know.
Thank you. I would like to know about the pollution. I mean, my understanding of Mumbai is quite polluted, even though you are next to the sea. Is that something of concern in terms of adopting natural ventilation strategies and design?
During the night time, we have seen a reduction in the pollution levels. That's why we had a scenario where we are opening for natural ventilations during the night time, whereas from morning, that is 7 to around 4 in the evening, it is we have seen the highest level of pollution, and it is considered to be unhealthy. That is why we need a combination of ventilation to be adapted. It doesn't completely work on natural ventilation at the present scenario.